Welcome to the Building Management System course. My name is Homer Velasco and I've been maintaining BMS and field systems for over 10 years as an instrumentation and BMS technician. Installation, troubleshooting, and monitoring of BMS sequences are all covered in detail in this course. This program is designed for people who want to pursue careers as BMS operators or technicians, which are in high demand right now. Upon completion of this course, the student will be able to know the importance of BMS on a system, knowledge in determining what sensors going to be used on a system, familiarize on 3 different systems that can be connected in BMS, understand the layer of BMS, find out how to terminate and wire a sensor to the DGP, identify the BMS network architecture, learn how to read and interpret circuit diagram, and learn the day-to-day job of a BMS technician or operator. BMS are intelligent microprocessor-based controller networks installed to monitor and control a building technical systems and services such as air conditioning, ventilation, lighting, and hydraulics. To put it more precisely, they connect the functionality of several pieces of building equipment so that they perform as a single and integrated whole. So what is intelligent processor control mean? This component can able to understand and store information in order to respond to varying situations and requirements by means of a software. So let's have an example. This is our field system, the controller, and BMS workstation. The controller receives the field system data signal and analyzes the program and then transmits it to the BMS workstation. Without requiring human intervention, field system and controller will communicate to alter the field devices. As an example, the controller might respond by stopping the field system functioning if it gets an alarm from the field system. And in the BMS workstation, all interaction between the field system and controller can be viewed. So this is the main controller of BMS. It is called DDC controller. DDC stands for Direct Digital Control. It has the ability to take input signal from field devices. As already discussed, the controller will store and evaluate all data from field devices. Hence, regardless of the controller's assessment findings, additionally, it will transmit an output signal to the field devices. The DDC controller has the capacity to preserve logic programming for field systems that operate automatically.